Okay, in this video we're going to be doing 16 AP Calculus multiple choice practice problems that apply to both the AB and BC exams. Problems are going to come from the 2016-17 curriculum framework put out by the College Board, which you can still definitely find online if you search around a little bit. These problems still definitely apply to the exam that you're going to be taking in May, so let's take a look at the problems. All right, number one, the limit as x approaches pi of cosine of x plus sine of 2x plus 1 all over x squared minus pi squared is. So every limit you should try to do by direct substitution. So step one, we're going to try to directly substitute. Cosine of pi is -1, sine of 2 pi is 0, and then there's a 1. So we get -1, we get a 0, and we get plus 1. So the numerator is giving us 0. And then in the denominator, we're going to get pi squared minus pi squared, which is just going to give us 0. So we are getting 0 over 0. All right, so this is a L'Hopital's situation. So we're going to have to apply L'Hopital's rule. So that'll mean that the limit as x approaches pi is, we're going to take the derivative of the top. The derivative of cosine is negative sine. The derivative of sine of 2x is going to be 2 cosine of 2x. Derivative of 1 is 0, all over derivative of x squared is 2x. The derivative of pi squared is 0, so that doesn't contribute anything. Now we sub in. The sine of pi is 0. The cosine of 2 pi is 1, so we're going to get negative of 0 and then plus 2 times 1, so plus 2, all over 2 times pi, which we can simplify and just get 1 over pi. So we are going to box the answer B. Number two, the limit as x approaches infinity, the square root of 9x to the fourth plus 1 all over x squared minus 3x plus 5. This looks like a L'Hopital's problem because you get infinity over infinity. This is a classic L'Hopital's loop problem, so you don't want to use L'Hopital's. The way you know that is you have this radical thing over a polynomial, and you're going to infinity. So what I'm going to do instead, I'm going to factor x to the fourth out of everything inside that radical. Let's take a look what that looks like. So we'll end up here. Limit as x approaches infinity, square root of, I've taken x to the fourth out, so I have x to the fourth quantity, 9 plus 1 over x to the fourth, and then all over the original denominator. Next step, square root of x to the fourth is x squared. That's all I'm going to do. The next step, divide everything I see by x squared, which is the highest power of x in the denominator. So highest power of x in the denominator, let's reduce everything by that. So I'll let you watch as I do this one. So the x squared in the numerator just cancels. X squared over x squared is 1. Then we get 3 over x. We get 5 over x squared. Now the beauty of this is that 1 or any constant over x to any power as x goes to infinity is 0. So all we have left is the square root of 9, which is 3 over 1, which is 3. So our answer is definitely B. I want to give you an alternative approach to this problem, though, because I do think it's useful sometimes to use this. It's safer to use this approach, though, when you are going to positive infinity rather than negative infinity. Negative infinity involves the absolute value. They also just don't ask about it as often. But if we're going to positive infinity, this is a safe approach. So I'm going to say at infinity, the square root of 9x to the fourth plus 1 is basically just the square root of 9x to the fourth, because what is that plus 1 really doing? And then that is 3x squared. Similarly, the x squared minus 3x plus 5, basically just x squared, right? Because at infinity, x squared is dwarfing negative 3x and plus 5, which means that our radical over our quadratic, basically 3x squared over x squared, which is exactly 3, same answer. Number three, the graph of a piecewise defined function f is shown in the figure above. The graph has a vertical tangent at x equals -2. That's going to be important. A horizontal tangent lines at -3 and -1. What are all values of x between -4 and 3 at which the function is continuous but not differentiable? So that vertical tangent line is going to be one of our answers because the derivative will be undefined, but the function is definitely continuous there because we can look at it and see that. So here's one of our answers. X equals 0, not continuous. Horizontal tangent lines, the derivative is 0, so that's fine. And then at x equals 1, you can look and see definitely not differentiable, but definitely continuous. Our answer is going to be C. Number 4, an ice sculpture in the form of a sphere melts in such a way that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. I'm going to write that down. dVdt is going to be negative 2 pi, and then it's cubic meters per hour, but that's not really going to play a role here, so I'm just going to not write it down. At what rate in square meters per hour is the surface area of the sphere decreasing at the moment when the radius is 5 meters? So we're looking for the rate of change of the surface area. I'm going to call that ds dt, I guess. So that's what we're looking for. And then we also know the radius is 5. All right, so this is our setup. We're told the surface area of a sphere. We're told the volume of a sphere. Since I know dv dt and I know r, I'm going to start with that and see where it goes. So volume is 4/3 pi r cubed. We need to find dv dt. So that's going to be, we're going to bring the 3 down, cancel. So 4 pi r squared, and then dr dt because of the chain rule. Now what we're going to do is sub in all the values that we know. So let's do that. We got negative 2 pi, got 4 pi, r we know is 5. dr dt we don't know, but we're going to be able to solve for it now. So that means dr dt is negative 2 pi divided by 4 times 25 is 100 pi. We can cancel some stuff and get negative 1 over 50. So now we know what dr dt is. Now let's go and use the surface area formula, which we were given. S is 4 pi r squared, so then ds dt is going to be 8 pi r dr dt. Subbing in what we know, we will get ds dt is 8 pi times the 5 times the negative 1 over 50. Simplify this, and we're going to get negative 4 pi over 5. Now think about it. They said that we wanted to find the rate at which this thing is decreasing. That's why all the answer choices are positive. So we're going to select A. Number 5, shown above is a slope field for which of the following differential equations? Okay, when I look at a slope field, the first thing I look for is horizontal lines, if they're in there. I see this one at y equals negative 1. You can count by 0.5s on this graph. You kind of have to look at that for a second. So when y is negative 1, the slope has to universally be 0. I look at the answer choices. I'm going to have to factor a little to make sense of this. So let's do that. So this one, you can take an x out, and we get x quantity y plus 1. Take a y out, get y quantity x plus 1. Okay, so if y is equal to negative 1, we need the slope to always be 0. If you look at what we have for A, if y is negative 1, you definitely get 0 no matter what x is. B, if y is equal to negative 1, you got to do something there. So B is not going to work. C, always going to be 0 when y is negative 1. D doesn't even have a y in it, so y equal negative 1 doesn't really have an impact. So we can definitely eliminate option B and option D. Now we have to choose between A and C. I'm going to go back and look at another horizontal line, just a random one, it doesn't matter. Notice that as x changes, the slope changes. That means that x is somewhere in this differential equation. We don't really need to know where, we just need to know it definitely factors in, which means our only option is A. If you're looking to get really good at these, I have a couple of matching a slope field to a differential equation videos where I go through a ton of them and just match them all up. Highly recommended. Number 6, let f be the piecewise linear function defined above. Which of the following statements are true? So it's piecewise linear. I think the easiest thing to do here is just graph it. I mean, it's not a hard graph to make. So got some axes. We know that 3 is important. If I plug 3 into the upper branch, I get 6 minus 2, which is 4. I'm going to put an open circle there because 3 is not included. And then just a line that I think has a slope of 2. And so that was for x less than 3. When x is greater than or equal to 3, we get 2 times 3, which is 6 minus 4, which is 2. So this will be a closed circle at 2. And then we need to just draw a segment that's parallel. There we go. All right, I think we can use this to answer our questions. Which of the following statements are true? If we find the limit as h approaches 0 from the left, that means that h is less than 0, right? Because to approach 0 from the left, you're in the negatives. So h is less than 0, which means 3 plus h is less than 3. So I'm going to draw a couple line segments here to help us visualize this. We would be going from a point to the left of 3 to the point at 3. Those are going to look like this. There is no way that that is going to equal 2 when we find that limit, because we're talking about like basically the slope of those lines. So this is not going to be true. So we can just cross this one out. All right, the next up, limit as h approaches 0 from the right. So this is the opposite situation. H is greater than 0, and if h is greater than 0, then you're using a number bigger than 3 and to the point at 3. But you can see here, if you fill it in, I used maybe a poor choice of color there. It actually is that line. That definitely has a slope of 2. This is definitely true. Let's look at the next one. So for, well, it's true. All right, for the next one, f prime of 3 equals 2. The only way that that could be true is if this thing is continuous, and then we would talk about the derivative, but this thing is not continuous, right? Not continuous at x equals 3, cannot be differentiable there. Therefore, this is not an answer. The only option that is true is B. Full disclosure, I definitely got this question wrong the first time I did it, so you really have to read these questions carefully. I looked at it and I was just like, yeah, from the left, you definitely get a slope of 2. From the right, you definitely get a slope of 2. I initially had chosen option C, and then I went back and I thought about it a lot more, and I was like, nope, not the right answer. So everybody makes mistakes, you just got to learn from them. Number 7, if f of x is the integral from 1 to x cubed of 1 over 1 plus the natural log of t dt for x greater than or equal to 1, then f prime of 2 is equal to, first we got to find f prime of x. This is going to be what in AP Calculus we call the second fundamental theorem of calculus. So what we're going to do is we're going to find f prime, which involves taking the upper bound, so the upper bound is x cubed, and subbing it into the integrand. So everywhere you see a t, replace it with x cubed. So that'll be 1 over 1 plus natural log of x cubed times the derivative of the upper bound. So we need to multiply by the derivative of this. That's the chain rule in action, so times 3x squared. So the question's asking us to find f prime of 2, so what we're going to do is take 2 and sub it in. So we'll get f prime of 2 is 3 times 4 is 12 over 1 plus the natural log of 8. And the answer choice for that is D. Number 8, which of the following limits is equal to the integral from 3 to 5 x to the 4th dx? First thing I like to do is look at the answer choice and make sure that like the function x to the 4th is being represented in each of them, because if it's not, we could just cross them out. But you can see these all have like the exact same form. So x to the 4th is accounted for. The next step is I'm going to try to figure out what I think delta x is in this process. So we're going from 3 to 5. So delta x is going to be the change in x. So it's going to be 5 minus 3 divided by n, which is going to be 2 over n. All right, now go to the answer choices. Look for 2 over n. You can see in A and C, they're using 1 over n for some reason. Who knows what it is? Those aren't going to be our answer. All right, now we have to choose between B and D. Well, I'm going to find x sub k, the evaluation point, right? So I would say on the AP exam, basically 100% of the time, it's not really maybe, but I think it is. 100% of the time, it's going to be a right Riemann sum. For a right Riemann sum, x sub k is going to be where you start plus k times delta x. So that's what we want to look at as what we're plugging into our function. You can see that in B, they've plugged in 3 plus k over n. And that's, using the wrong delta x there, I think. They're using 1 over n instead of 2 over n. In D, on the other hand, definitely the answer that we're looking for, so that's what we'll choose. Number 9, the function f is continuous from -4 to 4. The graph of f shown above consists of 5 line segments. What is the average value of f on the interval from -4 to 4? All right, so average value is just going to be the integral divided by the interval, so let's write it down. So we're going from -4 to 4 of the function divided by the interval from -4 to 4, which is 8 units long, but 4 minus -4. So this is going to be 1/8 of a bunch of geometry. Sometimes I think these questions that are in the exam description booklet that they put out are like rejected AP questions. Like this has a lot of work to be done for a multiple choice question, but who knows? All right, let's do some geometry on this. First triangle that I see, it's going to be 1/2, 2 times 1. It's above the axis, so it should be positive. The second triangle that I see is going to be 1/2, 3 times -2, which gives us -3. I'm then going to break this region into two things, a triangle and then a whatever. I guess a trapezoid, technically. This triangle is going to be 1/2 base times height is 2. And then this little trapezoid is definitely just 1 plus 1/2. So that right there is 1.5. Now you look at this and something really convenient happens. All of these things just sum up to 0. So all we're really getting is 1.5, which I'm going to write as 3/2 because looking at the answer choices, they're all fractions. So we get 3 over 16. So we are going to choose option B. Number 10, let y equal f of t be a solution to the differential equation dy dt equals k times y, where k is a constant. Values of f for selected values of t are given in the table above. Which of the following is an expression for f of t? All right, let's write it down. I'm going to color code it. I think that's really helpful. This is a separable differential equation, which is like in Calc AB, kind of the only type you need to deal with. Calc BC, there's a couple other things. So we're going to separate and then we're going to integrate. So everything with a y goes to the left. Everything with a t goes to the right, which in this case is just dt, but we're going to leave k there. Throw in some integral signs. It is my greatest shame that I cannot make an integral sign correctly as a calculus teacher. That's kind of sad. Integrate the left-hand side. Just don't forget the absolute value. So natural log absolute value of y equals k times t plus c. Before you solve for c, if y is inside a natural log, exponentiate. It does two things for you. I'm just going to do it. I'll link to a video below, I guess in the description, where I explain why this is happening, but we're going to get y equals a new value of c, e to the kt. Now we don't need to worry about that absolute value stuff when we're solving for c, which we're going to do right now. Look at the table. We know when t is 0, y, I guess, is 4. So we will plug in those values. So 4 is c e to the 0, which means c is definitely 4. Now that we know that c is 4, let's sub that in, and we'll go hunting for k. You can't really choose an option at this point because like weird things could happen when you do find k. Like I'd be inclined to cross out c and d as options, really, to be honest. But still, I think it's safer to try to actually find k first. Go to the table again, and we have 2, 12, so y is going to be 12, and then t is going to be 2. And we can solve for k, so we'll divide by 4, get this. Natural log of both sides gives us natural log of 3 is 2k. Divide by 2, and we'll get that k is equal to the natural log of 3 divided by 2. So then, if we take that and sub it in, we get something that looks a little different from the answer choice, but there's really only one that looks exactly like this. What they've done is they took the t and multiplied by 1/2 and made it t over 2 natural log of 3. The answer is definitely A, right? B doesn't look like that. C and D are ridiculous. That's our answer. Number 11, the graph of f prime, the derivative of the function f is shown above. Which of the following could be the graph of f? All right. First thing I noticed about the graph of f prime is that the graph of f prime exists for all values of x, at least on this interval. Therefore, f is definitely a differentiable function, which means f is a continuous function, which means that we can eliminate c and also d, but for some reason I didn't eliminate that here. I used the next piece of information to eliminate that. I don't know why. I look now at the derivative, and the first thing I notice is that at 1, the derivative is changing from negative to positive, which means there's got to be a minimum on the graph of f at this point. Now I looked at d and chose to eliminate it. I definitely could have eliminated that on the first step. I don't know why I did it that way. A and b are both still in the running, right? Because they both have a minimum at 1. So I look across and I see the next easiest thing to deal with is the fact that at 5, the derivative is going from positive to negative, so there needs to be a maximum. If you look at the answer choices at 5, A has a maximum, B has a minimum, B is out, A is our answer. There's a lot of other things we could do. Points of inflection, in particular, at x equals 3, there's a point of inflection. Because f prime has a relative minimum, I think that also would have sealed the deal between A and B. But anyway, our answer is definitely A. Number 12, the derivative of a function f is given by f prime equals e to the sine of x minus cosine of x minus 1 between 0 and 9. On what intervals is f decreasing? This is definitely a calculator question, so I'm going to switch over to the calculator. When I get there, I'm going to graph the derivative and just look for where it is negative, because if the derivative is negative, the function is decreasing. So I will be back after watching that to pick the answer. And so from all of that, we can see that the answer was A. 13. The temperature of a room in degrees Fahrenheit is modeled by H, a differentiable function of the number of minutes after the thermostat is adjusted. Of the following, which is the best interpretation of H prime of 5 equals 2? All right, so let's reread the problem and find what we need to know. First, we're talking about H prime, so we need to know what H is telling us because H prime is the rate of change of that. So looking at it, H is definitely the temperature of a room in degrees Fahrenheit. All right. Now we need to figure out like what is the 5 telling us. So H is a differentiable function of the number of minutes after the thermostat is adjusted. So 5 is the number of minutes. So it's 5 minutes since you adjusted the thermostat, and that's the rate of change of H at that time. So 5 minutes after you adjusted the thermostat, the temperature is increasing by 2 degrees Fahrenheit per minute. That's going to be the answer. Let's look at the answer choices. You basically have to read them all to figure it out. A, the temperature of the room is 2 degrees Fahrenheit 5 minutes after the thermostat is adjusted. No, that would be H of 5 is equal to 2, not H prime, so that's out. B, the temperature of the room increases by 2 degrees Fahrenheit during the first 5 minutes after the thermostat is adjusted. That's just not what it means. That would have to be an integral type of thing, right? To find the total change, you would have to like integrate H prime, I guess. Or I know. C, the temperature of the room is increasing at a constant rate of 2/5 degree Fahrenheit per minute. This is a weird misunderstanding of what's going on. That's like an average rate of change, I guess, if you thought that, like, I mean, I don't even know. You'd have to be very confused to choose that. That's not the answer. And then that, by default, will make D the answer. Temperature of the room is increasing at a rate of 2 degrees Fahrenheit per minute, 5 minutes after the thermostat is adjusted. And that's basically what we said. I'm going to link below to a video where I describe exactly how to interpret a derivative in context because these come up frequently. 14, a function f is continuous on the closed interval. So continuous, suspicious. What aren't they saying there? They're not saying that the function is differentiable. I always make a note of that, even before I finish reading the problem. Like, why are you only telling me continuous? All right, continuous on the closed interval from 2 to 5. F of 2 is 17. F of 5 is 17. Which of the following additional conditions guarantees that there is a number c in the open interval 2 to 5 such that f prime of c equals 0? Sounds a lot like the mean value theorem to me because we know things about f and we want to say something about f prime, which means we would need the function to be differentiable on the open interval, continuous on the closed. I think that's going to be the answer. Let's look at the answer choices. No additional conditions are necessary. That's not true because we don't know if it's differentiable, so it just doesn't need to have f prime equals 0. F has a relative extremum in the open interval. Not necessarily the answer. C, f is differentiable in the open interval. That's definitely true because it sets up the mean value theorem. And then D, I don't really know why this would be an option. The integral from 2 to 5 of f of x dx exists. I don't know. They just need 4 choices, I guess. Now, why doesn't B work? Well, we could draw something not differentiable where there is a relative extremum. So always keep in mind the absolute value of x. I think that's the best example of a continuous not differentiable function. But anyway, our answer is C, which we kind of knew as soon as we saw continuous but not differentiable given. 15, a rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. The height of the water in the barrel increases at the rate of r of t, which is 4t cubed e to the negative 1.5 t feet per hour, where t is the time in hours since the rain began. At time t equals 1 hour, the height of the water is 0.75 feet? I don't know. What is the height of the water in the barrel at time t equals 2 hours? All right, so in general, what we're doing here is just the amount we start with plus the displacement. Clearly, we're going to use a calculator because nobody's integrating that thing by hand, and also this is a calculator question. The one thing to watch out for is that you are not given the amount at time 0, you are given the amount at time 1. So when you set it up, you have to do the integral from 1 to 2, not from 0 to 2. So just be on the lookout for that. I bet that's one of the wrong answers. I didn't try it. I'm going to switch over to the calculator and I will do the problem and then I'll be back to select the answer. And so from all of that, we can see that our answer is D. 16, a race car is traveling on a straight track at a velocity of 80 meters per second when the brakes are applied at time t equals 0. From t equals 0 to the moment the race car stops, the acceleration of the car is given by a of t equals negative 6t squared minus t meters per second per second. During this time period, how far does the car travel? All right, so we're looking for distance traveled on a time interval that we don't know for a function that we were not given. This is why I feel like this is not a real question that would have been on the exam. Who knows? It's got a lot of steps, though. First thing I'm going to do is I'm going to find v of t. I'm going to do that by hand because you're not required to have a calculator that can find an antiderivative. So let's do that. So we're just reversing the power rule. So v of t is going to be plus 1 times the reciprocal. So negative 2t cubed minus 1/2 t squared plus c. We know that v of 0 is 80. That's given in the problem, which means that c is 80. And so our velocity function that we're going to work with is negative 2t cubed minus 1/2 t squared plus 80. So now what I'm going to do is I'm going to go over to the calculator. I'm going to graph this thing, find the 0. I'm going to integrate it on that interval, see what I get. Then I'm also going to do it on a calculator page. So I'll give you 2 different options for how you can find the value. All right, so I will be back when we're done with that, and we will choose the answer. All right, and then based on our calculator work, we now know that the answer is B. All right, that's 16 good questions that you can use if you're in Calc AB or BC to study for the exam. I hope you found this helpful, and good luck.